Professor Moyo, Professor Kannur, Pratisha Madam, and the coordinators for giving me this opportunity for sharing my views on the topic of mathematical biology. So shall I share my? So see, in this scenario of era of artificial intelligence and machine learning, we are interested in processing huge data using machines and making them intelligent in the sense that they could be brought, their behavior could be brought as nearer to the human as possible. Uh, One of the fields of doing that is also handling the vagueness in the data or in the talks that we do. So how that machine can interpret them. Uh, so this can be dealt easily with using the fuzzy setup. So I'm taking the case in mathematical biology to have more hands on the control over the machines in particular area. First, we need to understand the process, and once we do that, we will be able to guide the machines to to process and behave in a as desired in a way that we desire. So I have taken few setups, few processes from the mathematical biology. Uh, this will be the outline of my talk, a bit of the things which are required. Then I have taken the cases of diabetes, which is the most prevailing, and the concern disease, so that we are able to handle and aid the doctors to understand it. They of course they do understand it very well, but maybe more the mathematical tools will allow them to have more hand over it. Then another one is same diabetes, but then how it should be maintained. And if the time permits, I'll take even the third case, cancer treatment using radiotherapy. So we know that the diabetes mellitus is a it occurs due to the sugar levels in the bloodstream. So what happens is when the body is not producing enough insulin, it becomes resistant to the insulin that it produces, and then the glucose is not digested, and it remains in the blood. So that's the process of excess of sugar in the blood, which is called diabetes. So there are kind of these are the cases which are there worldwide, huge number of cases, and uh, the prevalence is increasing day by day. These are the types of diabetes that you have: type 1, type 2, and gestational. The type 1 is a kind of from birth. It's a autoimmune condition where the immune system attacks the insulin producing cells itself, which are produced by pancreas. So it is due to genetic or environmental factors. So this without enough insulin, the sugar cannot enter body cell and to be used as the energy. Instead, the glucose remains in the bloodstream, and this leads to the higher blood sugar levels. So that is type 1 diabetes. In type 2 diabetes, what happens usually over time due to the lifestyle factors, um, uh, like poor diet, lack of exercise, obesity, and other factors, it becomes resistant to insulin, and so that means it cannot efficiently use insulin. And initially, the pancreas compensate by producing more insulin. But as time progresses, it tires it, it gets tired and fail to produce enough insulin, leading again. So since the glucose is not digested, not taken in the cell for the energy conversion, it remains in the blood, again leading to the high blood sugars in the blood. So, how are we able to identify these kind of things? So, there are factors like the increase in thirst, hunger, or frequent urination, fatigue, blurred vision. So these are the kind of factors which indicates that there is some disorder in the blood, or there is a increase of sugar in the blood. And in India, there are nearly 10 crore cases out of 142 crores. So uh, uh, quite a good figure. Yeah. So we should be trying to understand it and try to take measures which can prevent it. Okay, type 1 diabetes, of course, cannot be prevented. Rather, it then has to be maintained. It has to be controlled in a way so that the patient can live a good life. So uh, uh, because what happens that if it is not maintained properly, the control of the disease is not done, then it may lead to the damage to the vital organs like heart, blood vessels. And if it is affecting the blood vessels, it we may get stroke leading to paralysis and all that. If the eyes are affected, glaucoma and other things develop faster. If damage to the kidney is happening, then kidney failures and all that. So the complications are severe. If the diabetes is not handled or controlled properly, it could lead to severe complications later in the stage. So we should prevent, which can be done in the by type in the case of type 2. Here, for the understanding, I have taken only the type 1 diabetes to maintain to control the type 1 diabetes, understanding it mathematically, where the data may not be very precise. So, as I told you, that when you are trying to understand the population which is suffering diabetes, and later on they may have transited to the case where the complication has developed. So, two kind of population. What is the dynamics between these two kind of population is to be understood. So the size of population of the people which are suffering diabetes may not be exactly known, right? Because of non-reporting of the cases, or even that if it is known, then how many are have reached to the stage where complication has developed. That cannot be correctly judged. People may overlook. Okay, I am just a diabetes patient. Still, no complication has developed. So that kind of transition from being a diabetic to being a diabetic with a complication, again it is vague. You cannot precisely estimate that number. So we I have considered or modified a model with by representing the things as a fuzzy, right? So there's the dynamics of the people who are suffering from diabetes without complication, with complication. So you have the incidence, you come to know that a person is diabetic. That is the complete diabetic population. Then without complication, and the C indicates that it is with complication. Then the rate of the person who is suffering from diabetes is indicated as minus lambda, because the person who now has developed a complication will go to the category of complication diabetic person with complication. So that amount of person would decrease from this equation, and rather it would enter into the C dash, the rate of change of person with complication. And they may even mortality rate, due to mortality rate, the number of persons suffering from diabetes may decrease. Also, the from the complicated ones, those who have practiced a good amount of strategy for controlling it, they may now the complications may have vanished. So those from the complication with the complication patients, few of them recover and they just have to control now. They have overcome the complication. So those many persons will come here. And that way, the complete dynamics is understood. These are the differential equations, or system of differential equations. Here we have mentioned that all the rates that are involved in the dynamics are crisp. So this is the basic model. But as I told you that these numbers may not be precisely known. They may be due to the cases that has been registered. They may not be completely known. So I modified these two equations as a fuzzy one. So these are the notations. And once it is decided that uh, it is fuzzy, I will consider these factors to be fuzzy. Also, when I'm trying to start this study the population of, let us say, some local region, the number of cases that I start with, which I'm calling as C0 N0, may also not be exact. It depends on the region that I have considered. And therefore, again, they may be a bit vague, but they not be totally precise. In this equation, when you're trying to see the parameter lambda, that parameter may be considered as constant. It is a probability of diabetic person who will be later on developing the complication. So if that is considered to be constant, the dynamical system given by B would be linear. But if it is taken to be the fraction of the complication developed patient to the whole population, then that would be considered as non-linear. So I had tried to analyze the non-linear case by considering lambda to be function of CT and T, and beta is the rate by which it is the probability is considered. And also this beta, I have considered it to be fuzzy. So therefore, the dynamical system that I'm considering is would be N0 is the total population, the person with diabetes with and with complications. So all are CT, DT, both are diabetic patients, but CT is the patient who has also developed the complication due to diabetes. N is total of that too. So once we have considered this ratio, as I told you, I'll be considering them as a fuzzy. So first, just a brief of what do we mean by fuzzy number. So fuzzy is a case whenever you take an object in a set, then that object is either in a set or is not in the set. So the statement itself may be seemingly vague to you. That, for example, if I am talking about the cloudiness in the over the day light, then a person may say it is cloudy, it is very cloudy, it is less cloudy. So cloudy is not just yes or no kind of thing. It may be a degree to which it is cloudy. We may like to say that. Or when you're talking about the weather, then somebody may say it is a pleasant. For others, it may not be that good for them. They may not like that kind of weather. So the things are not crisp 0, 1. They are in the range, in the interval 0, 1. So whenever mathematically it is said to be in the interval 0, 1. So whenever you cannot precisely bifurcate the data or dichotomize the data, you try to rather put them in the interval 0 to 1. So those are the concept represented by the fuzzy numbers. So for that, I'll give you that how it started. The fuzzy concept. Initially, we just had the Boolean logic. That means either true or false. So represented by 1 or 0. In 1965, Yade extended this to the multi-valued thing. So instead of just 0, 1, he said that no, there can be multiple values occurring in the range 0, 1 rather than just 0. So that way the fuzzy sets came into existence. So every element of the set is now given membership. It is not that if the element belongs to the set, it has membership 1. It may belong to only certain degree. So it's a kind of a person standing on the door near the door frame. So he is inside the room or outside the room, you don't know, right? So he may be half the step inside the room. So you can say that okay, 0.25 belongs to the room with 0.25 value. That is a kind of membership you can associate to the element. Okay. Mathematically, if I am saying this graph, if you can see it. So the membership value to each element on the set associates the value 0, 1. So here we can see that it is a kind of Gaussian shape associated to the elements given in the set. Uh, that means the element at which it is at the peak, that element is having the highest membership value, and the remaining on the left and the right of that element are having lesser membership values. If this height that I have is 1, that means the maximum membership value of the element is 1, then that kind of set is said to be a normal fuzzy sets. These fuzzy sets we can cut by taking some value of alpha. For example, this mu I. Suppose at that point, the point at which it is written, if I cut this set and take the projection on the x-axis, this is the interval where each of the elements are having membership value more than this mu, right? So if I take such cuts, if I go on taking, and each cut is of close interval, then and even the support means the elements which are having the membership value more than 0 is bounded, then this fuzzy set, if it is satisfying all these three properties, is represented as a fuzzy number. So with fuzzy set, you can just do the operations that we can do on the sets, like take the union, take intersection, take complement, and all that. But once these fuzzy sets qualify as fuzzy numbers, you can do the arithmetic that you can do on any number, like we had been doing on real numbers, complex numbers. Similar to that, there are operations that you can perform on fuzzy numbers. And why do you require that? Because our intention is to solve the dynamical system. So when you want to have the insight in the process, which are represented by the differential equations, and the number, the parameters or the initial conditions which are given are vague, then you would like to represent that kind of system using the fuzzy concept. So one such example of fuzzy number is this triangular fuzzy number phi minus 1 0. Why I say minus 5 minus 1 0. So it is extending the maximum, uh, the element minus 5 is having membership value 0. The maximum value is for the element minus 1, which is 1 membership value. And then again it decreases to 1. Right? 1 at 1 it becomes 0, and the other elements apart from which are lower than minus 5 and higher than 1 do not have any membership value. That means they belong to this fuzzy set with a membership value 0. So algebraically, this is how it can be denoted. And whenever there is a dynamical system which is involving fuzzy numbers, so how to solve those kind of dynamical systems? So one way is to take the alpha cut. That means you are trying to take the projections of the cut on the x-axis, and with those projections we are trying to study the system. So we take this alpha cut, and that this is particularly shown for alpha equal to 0.5. When you see 0.5, the interval for which the membership values is more than 0.5 is minus 30. Okay, so there's a typo mistake here, it's minus 30. Okay, so once similarly you have different alpha cut. So this is the parameter or the general parameter value by which we would be working down. So with this setup, I'll just go to the again to our system that we wanted to study. So now the things are the population that was with the complication C is fuzzy. The total population is also considered to be fuzzy, and the other parameters. Whenever you have such a dynamical system to be studied, first we try to see whether this system will be stable or not. For that, we try to get the critical point. That means considering that there won't be any change with time. So CT and T, C dash T and dash T on the left, which are there, are taken to be 0. And by that, so you get the nonlinear system of algebraic equation. So that we solve, and because it is quadratic, you get to trivial points. those critical points may be trivial, may not be trivial. For each of these critical point, we are trying to analyze the behavior. Now, this fuzzy system cannot be directly solved. Although I said we take the alpha cut and solve, it is not that much easy. You require a method which can handle the nonlinear equation in fuzzy sense. So for that also we developed some scheme parallel to the Newton-Raphson and all that. Again, we require the Jacobian also. There are other methods like Edovian decomposition method and others. We can solve these nonlinear things. Once we have these critical points, we see whether it would be a kind of a point which will not be stable. So the trivial point is saddle point. So when you come from one side, you feel that it is increasing. From the other view gives us that, okay, it is decreasing. So that kind of non-decisiveness is there called saddle point. Other points are stable and spiral sink that it will freeze down and the diabetic may be controlled when it is properly handled. So this is all mathematics going on. I have developed even the numerical method to check the evolution that from some population estimate whether it will converge or diverge. So there are two numerical methods being proposed for this, and they are being analyzed. They do converge. So first numerical method, second numerical method, and I'll go to the graphical representation so that so if it is not handled properly, we can see that how the population will grow, and so it is very much required to see the check the maintenance, and it should be under control. These are the population things. Okay, once we have estimated the population, we would also like to see whether a person who is trying to maintain can have a controller. So for that, I had taken a linear quadratic control problem is studied. I'll go to again. So it was using Hamiltonian. The study was done where you have the hum performance index, which is to be minimized with some dynamics for the person to check whether the things can come to the control or not. These are all the theory involved in the control. So these were the taken values for the glucose and the hormone level. So this hormone is then allowing the insulin to be secreted, and then the glucose is being digested so that cell can produce the energy. We can see that here, starting with this range between near to 30, it is decreasing. So if you take medicine and the precaution, the glucose level can go down. So it can be controlled. So these are the two cases that I had studied. Even the cancer, disease, cancer using radiotherapy was studied. Here you had a non-linear dynamical system, which was solved using Edomian decomposition. Uh, and for certain, again, here we have taken vagueness because when we are trying to give the radiotherapy, it is not that only the cancerous cell would die, even the healthy cells are getting affected. So with that, the treatment, we want to know that where the precisely the radiotherapy should be given. And once the dynamic is studied, this is how it is affecting the healthy cells and cancerous cells. So these are certain mathematical, biological systems which are to be analyzed for the better understanding uh, of the diseases. So mathematics do play a role in this. That's all from my side.